Welcome to Simplified Physics. In this lecture of dimensional analysis, we will discuss some problems related to the dimensional analysis. Let's begin with before starting the problems on the dimensional analysis, we must have some basic concept on the dimensional analysis. For more details, I suggest to view the previous videos on the dimensional analysis. You must know about the principle of homogeneity of the dimensions. According to principle of homogeneity of the dimensions, each term in the physical relation have identical dimensions. Second point, you must know about the physical relation. Two or more terms in a can be added or subtracted if they have same dimension. In such conditions, we can add or subtract two or more terms in a physical relation. And moreover, to determine the dimensions or to solve the problems related to the dimensional analysis, you must have some ideas about the units, dimensions, or physical relation concerning the physical quantities. If you know these 3 points, you can solve any problems related to dimensional analysis. For more detail about these descriptions, these points, you may see the previous videos. Let's begin the problem. The very first problem: determine the dimensions of a thermal conductivity. Let's begin with to determine the dimensions of a thermal conductivity. You may know the physical relation relating to the thermal conductivity. A relation concerning to the thermal conductivity is Q equals to Ka theta 1 minus theta 2 into T whole by D, where Q is the heat energy, A is the cross-sectional area, K is thermal conductivity, theta 1 minus theta 2 is the temperature difference in temperature, T is time, D is thickness. Now we have the given equation or the relation, physical relation concerning with the thermal conductivity. That equation we can rewrite as K equals to Q into D divided by A theta 1 minus theta 2 into T. In terms of dimension, we can write this relation: dimensions of the K equals to Q. Q is the heat energy. Heat energy has the dimension of energy or work done. Work done has the dimension mL2T minus 2. If there is any confusion with the dimension of the heat energy, compare with the energy. Energy has the dimension mL2T minus 2. If you are confused with this dimension, go for the work done. Work done is simply defined as force into displacement, and force has the dimension mLT minus 2 and displacement has a dimension L, so you will get mL2T minus 2. Now D is the thickness, length, breadth, whatever. It has the dimension L, and dimension of the area is L square. It's obvious. And difference of theta 1 minus theta 2, that's difference, has the dimension K, and T is the dimension of the time. To simplify it, you will get relation M1 L1 T minus 3 K minus 1. So dimensional formula for the thermal conductivity is M1 L1 T minus 3 K minus 1. So we can say that dimensions of thermal conductivity are 1 in mass, 1 in length, and minus 3 in time, and minus 1 in temperature. In this way, we can find the dimensions of a thermal conductivity. Once again, we check in brief. Now let's go for the second problem. Find the dimensional formula of coefficient of viscosity. So begin with the physical relation involving the coefficient of viscosity. A simple relation relating the coefficient of viscosity, force equals to minus eta A dv by dx, where dv by dx is called velocity gradient. So in terms of dimension, we may write dimension of the formula is ml t minus 2. We have to determine the dimension of coefficient of viscosity eta, and A is the area is the dimension L square, dv is the small velocity or change in velocity, that is lt minus 1, dx is the distance L. So in this way we can write in terms of the dimension. Then begin with or simplify it, you will get the dimension ml minus 1 t minus 1. This is the dimensional formula for the coefficient of viscosity, and coefficient of viscosity has the dimension 1 in mass, minus 1 in length, and minus 1 in time. So dimensions of the coefficient of viscosity are 1 in mass, minus 1 in length, and minus 1 in time. Though this in general ml minus 1 t minus 1 is called dimensional formula of coefficient of viscosity. Now let's go for the next question. Determine the dimensional formula of the electric charge Q, potential V, capacitance C, and resistance R. Now for the first one, electric charge, the physical relation involving the electric charge, simply Q equals to IT. I equals to rate of change of, I is electric current is defined as rate of change of electric charge, so simply Q equals to IT we can write. Now dimensional formula for the Q is, for electric current I is A, for time t, so we can write Q equals to, dimensional formula for Q is AT. But some authors prefer that dimension of the electric current as I. If we choose dimension of the electric current as I, we get a dimensional formula for the Q is IT. So be careful with in multiple choice questions. If the option has A, you may write A as a dimensional formula for electric current. If MCQ has an option with I, choose the dimensional formula for electric current as I. As per requirement, you may choose, both of them are correct. Then let's go for the second part of the discussion, the physical relation for the electric potential, or relation involving the electric potential is U equals to QV. Q has the again IT times B, and U is the energy. So dimensional formula for the energy is ml, electric potential energy. So it's a simply use the dimension of the energy ml 2 t minus 2, and obviously Q has the dimension AT, or simply I into T from this one you may write, and B after V we are finding the dimensional formula. So B equals to, simply we get the dimensional formula as m L minus 2 t minus 3 A minus 1. Now let's go for the next, third part of the discussion. The third part, we have to find the dimensional formula for the capacitance in the third part of the same question, and the physical relation involving the capacitance is Q equals to CV. And let's go for, in terms of dimension, we may write for the Q once again 80. After capacitance we have to find, and dimensional formula for the V is just, we have found ml2 t minus 3 a minus 1, so replace it and just simplify. We get dimensional formula for the capacitance as m minus 1 L minus 2 A2 t power 4, isn't it? Check it once again, take your time, pause the video if required, and proceed. Now let's go for the last part of the discussion. The physical relation involving the electrical resistance is B equals to Ri and we are familiar with the I has a dimension a. After r we have to find the dimensions for this. So after v we have just found before m l2 t minus 3 a minus 1. So the dimensional formula for the electric current as m l2 t minus 3 a minus 2. In this way we can find the dimensional formula for the various quantities. Now let's go for the next question. If q be the dimensions of the electric charge, find the dimensions for the electric current. Sometimes dimensions may be mentioned in the question. If not mentioned, we choose 7 different base quantities. Quantities are chosen as the base dimensions. So now in this case q itself given as a dimension, then what will be the electric current dimensions of the electric current? Q equals to IT, basic relation. Q as the dimension as Q I. After electric current we have to find a dimension for the electric current, then T as a time, then we'll get the dimensional formula for the electric current as m0 l0 t minus 1 q1. So dimensions of the electric current are 0 in mass, 0 in length, minus 1 in time, and 1 in electric charge if charge has the dimension q. Let's go for the next question. If force, velocity and time are chosen as a base quantities, in general mass, length and time are the base quantities, but in this question it is mentioned as force is a base quantity, velocity as a base quantity and time as a base quantity, then what will be the dimension of the mass? So let's see. Base quantities are force, velocity and time. It is mentioned in the question. Then a physical relation involving the mass is F equals to ma. In terms of dimension we may write the one more step, F equals to m b by t. Now in terms of dimension, F has the dimension F, it is mentioned in the question. After m we have to find the dimension velocity b has the dimension b, it is mentioned, and time has t. Then dimensional formula for the mass in terms of f, b and t is f1 b minus 1 t1. Then we can say that the dimensions of mass are 1 in force, minus 1 in velocity and 1 in time in terms of the force, velocity and time. If we choose the force, velocity and time as the base quantities, then dimensions of the mass are 1 in force, minus 1 in velocity and 1 in time. In this way we can find the dimensional formula if the base quantities are mentioned in the question. Now let's see one more question, same as question number 5. Choosing force, length and time to be the fundamental quantities. Base quantities are in this question force, length and time, not a mass, length and time, different from the conventional question. So find the dimension of the density in terms of the FLT. Let's see. FLT are the base quantities. Then the physical relation involving the density, the very basic formula, rho equals to m by v, and mass is not a base quantity, so converting to force, mass is defined as force by acceleration and whole divided by f, and further simplify f by av. Then in terms of the dimension, dimensional formula for the rho is, for the f, dimensional formula f, it is mentioned in the question, and a is the acceleration expressed in terms of L and T, because L and T also the base quantities, so we can write as LT minus 2, and volume as the base quantity L, it is L mentioned in the question, so we can write L cube as for the volume. Just simplify it, we will get F1 L minus 4 T minus 2. So this is the dimensional formula for the density. So, and the dimensions of the force in terms of force, length, not a dimension of the force, dimension of the density in terms of force, length and time is 1 in force minus 4 in length and 2 in time. Let's see one more question. Young's modulus of a steel is 19 into 10 power 10 Newton per meter square, or simply 1.9 into 10 power 11 Newton per meter square. Now express it in dyne centimeter. Here dyne is a CGS unit of force. That means simply Newton per meter square is the SI unit of Young's modulus, and dyne per centimeter square is the CGS unit of the Young's modulus. We have to convert from SI to CGS system. Let's begin with the unit of Young's modulus, Newton per meter square. It is obvious, and it includes the dimension of the force Newton and distance meter square. So force has the dimension you are familiar with, mlt minus 2, that is the Newton as well, and distance or meter square has the dimension L square. So dimensional formula for the Young's modulus, y is mlt minus 2 by L square. Simplify it, we get as m1 L minus 1 t minus 2, and it assume as ma lb t by c. So dimensions are 1, minus 1 and minus 2. So a equals to 1, b equals to minus 1, and c equals to minus 2. Now we have to convert from SI system to CGS. It is given that n1 equals to 19 into 10 power 10, and n2 we have to find. In SI, the unit quantity for the mass is 1 kg. In CGS, unit quantity for the mass is 1 gram. Similarly, unit length is 1 meter. Unit quantity for length is, here is also mentioned 1 meter. In fact, it is 1 centimeter, 1 centimeter, 1 meter, and 1 centimeter here. L2 is 1 centimeter. Similarly, time 1 second, 1 second. Then just apply the relation n2 equals to n1, m1 by m2 whole power a, l1 by l2 whole power b, t1 by t2 whole power c. How does this relation comes? If there is any confusion with this relation, I suggest to see the previous videos, and we'll get n1 value of n1 replace the values 19 into 10 power 10 in SI. Unit quantity is 1 kg. In CGS, 1 gram. L2 is 1 meter. L1 is 1 meter. L2 is 1 centimeter, and T1 is 1 second. 1 second. And about the power, A equals to 1, B equals to minus 1, and C equals to minus 2 on the basis of dimension of the Newton per meter square. Now convert the 1 kg into gram, so we can cancel gram, or simply 1 gram into kg, we can cancel kg. So for more simplification, I have converted kg into gram. 1 kg equals to 1000 gram, 1 meter equals to 100 centimeter, and once again cancel, or simply 1 power of 1, whatever the power of 1 is, always 1, and centimeter cancel, it gives to by 100, 1 by 100, because negative power is here, 1 by 100, and in this case gram cancel 100, so two zeros cancel. So simply you will get n2 equals to 19 into 10 power 11. 19 as its number, 10 power 10 here. 20 cancel because it has negative power, and 0, one more 0, that means 10 power 11. n2 equals to 10 power 11. Thus 19 into 10 power 10 Newton meter square equals to 19 into 10 power 11 dyne per centimeter square. In this way we can convert one system to another system. In the previous example, during the discussion of the application of the dimensional analysis, we have discussed an example conversion from CGS to SI. I will suggest to see that video as well for the to know more details about the conversion of the from one system to another system. And this is the end of the lecture. Thanks for watching. Welcome to Simplified Physics. In the previous lecture of dimensional analysis, we have discussed about the problems under dimensional analysis. Some problem we have discussed. In this lecture, we'll discuss some more problems related to dimensional analysis. And don't forget to subscribe, share, like and comment. I'm waiting for your suggestion. May forward to the comment or to the mail link address you may forward to. Let's begin today's lecture. The first problem is 60 joule per minute on a system. We have to convert into a new fundamental systems which has 100 gram, 10 centimeter and 1 minute as a fundamental units. Let's convert. How to convert 60 joule per minute? The given physical quantity here is 60 joule per minute. Convert into 60 joule per second. So 60 joule per minute into joule per second, that is 1 joule per second. And the dimensional formula corresponding to the 1 joule per second is, now for the joule, it's a unit of the work done, that is ml2 t minus 2. This is the unit of time, so t simply we'll get m1 l2 t minus 3. So the given physical quantity has the dimension 1 for the mass, 2 for the length and minus 3 for the time. That means simply a equals to 1, b equals to 2 and c equals to minus 3. Those are the dimensions for the given physical quantity q. Now let's convert for a given system and to new system. n1 equals to 1 is given, m1 1 kg, l1 1 meter and t1 1 s for the SI system, that is joule per second. Now we have to convert to the new system and find the value of the n2, and m2 is mentioned, that is 100 gram, l2 is 10 centimeter and 1 minute, t2 that is as a new fundamental units. Now use the relation n2 equals to n1 m1 by m2 power a, l1 by l2 power b, t1 by t2 power c. Just replace the values. n1 equals to 1, m1 equals to 1 kg, m2 equals to 100 gram is here. Similarly replace l1 by l2 power b, b equals to 2. Similarly t1 by t2 power c. Now convert into the similar system for the first term. This term 1 kg equals to 1000 gram and 100 gram, as it is gram and gram cancel, 2 zeros cancel, that is 10 is left from the first term. Similarly 1 meter equals to 100 centimeter, 10 centimeter as it is cancel once again, centimeter cancel, 0 and 0 cancel, square of 10 is left, that is 100. And similarly convert into 1 minute and simplify it, you will get these values. 10 into 1000 into 216,000. Simply n2 equals to, we will get 2.16 into 10 power 8, and we can conclude that 1 joule per second, or that is 60 joule per minute, equals to 2.16 into 10 power 8 new units. And new system of unit is not mentioned, just mention as new units. In this way we can convert from one system of unit to another system of unit for a given physical quantity. Now let's begin for the next problem. The unit of the length, mass and time are doubled. Is there any changes in numerical value in the measurement of the energy? The given physical quantity is energy And the dimensional formula for the energy is ml2 t minus 2. So energy has the dimension m1 l2 t minus 2, that is mass has the dimension 1, length has 2, and minus 2 is the dimension of the time in case of energy. Now we have to convert from the, we have to check whether there is any changes in the numerical value. So use this formula: n2 equals to n1 m1 by m2 power a, l1 by l2 power b, t1 by t2 power c. The condition is mass, length and time are doubled. So just replace the values in the formula. n1, there is no idea is there any changes in the n1. n2, so n1 it is given as it is m1 equals to, suppose 1 kg. If 1 kg is chosen as m1, then the quantity mass is double, so m2 must be 2 kg and a equals to 1, dimension of the mass. Similarly 1 meter, if chosen for the L1, L2 must be 2 meter, and 1 second, 2 second, b equals to 2 and c equals to minus 2. Same way. Now cancel the kg, that is 1 by 2 power 1. Cancel the meter, that is 1 second 1 by 2 power 2. Cancel the second, that is 1 by 2 power minus 2. 1 by 2 power minus 2, 1 by 2 power 2. These two terms are cancelled. 1 by 2 is left, so n2 equals to half of n1. So numerical value will be half of the original value. In this way we can convert, or we can simply find how there is the variation in the numerical value of a given physical quantity from one system of unit to another system of unit. Let's see the next problem. The next problem is the distance covered by a particle in time t is given by a relation s equals to a plus bt plus ct square plus dq. Find the dimensions of a, b, c and d. The most important point is 2 or more terms can be added if they have identical dimension. That's an important point. And dimension on the each term on the left side must be same as dimension on the right side. So each of these terms, yes, a, bt, ct square plus ct and dq, all must have same dimension. All these 5 terms must have same dimensions. So dimensions of S must be same as dimensions of A. Here S is the distance covered, so dimension of the S is L. So as dimension of the A is same as dimension of the S, dimension of A also L and S. Now again, dimension of BD is same as dimension of the L, sorry, dimension of the S or dimension of the A. Dimension of the A must be same as dimension of the BD. So A, B, T is the time, dimension of the time is T. So dimension of the A is L, dimension of the B and T as well. So dimension of the B is simply LT minus 1. Similarly, we can find the dimension of the C and D as well. Let's try to find on your own. Pause the video and proceed to find dimension of the C and D as well. In this way, we can simply find the dimension of A, B, C, D. The most important point is all the terms in a physical relation must have the same dimension. We use just and 2 or more terms can be added if they have same dimensions, and the dimensions on the each term on the left side and the right side must be same. Using this concept we can find the dimensions if two or more terms are present in a physical relation. Now let's see the next problem. A student writes r by 2gm whole power half, that is square root of r by 2gm for a escape velocity of dot. Check the correctness of the formula using the dimensional analysis, where r is the radius of dot, g is universal gravitational constant, and m is the mass of the earth. Let's begin. Escape velocity v equals to r by 2gm whole power 1 by 2. It's a formula given by the question, or simply a student writes this as a escape velocity. Now we have to check whether this formula is dimensionally correct or not. In terms of dimensions of LHS b is, that is velocity lt minus 1. Similar dimension of the right side, r is the radius length, whatever, it has the dimension l. 2 is the numerical value, that is simply the number, it has no dimension. G has the dimension m minus 1 l3 t minus 2, and m is the mass has the dimension m. And simplify it, you will get l minus 1 t minus 2, that is m cancel, and remaining quantity just simplify, we will get as l minus 1 t minus 1. So what's your conclusion? Dimension under LHS is not equal to dimensions under RHS. So we can conclude that the given physical relation for the escape velocity is dimensionally wrong. Now let's go for the next problem. Once again, a student reports that the time period of a helical spring is t equals to 2 pi m by k, where k is the force constant. Is he right? If not, what is the correct equation? The physical equation according to question, time period t equals to 2 pi m by k. 2 pi is a dimensionless number, and dimension on the LHS t is obviously time period t, and for the dimension on the RHS, that is 2 pi is dimensionless, dimension after m. Before once again, m as a mass, and what is the k? K is the force, constant force per unit length, simply ml by f. M is the mass has the dimension m, l is the length, dimension l, and force has the dimension ml t minus 2, that is simply ml cancel, that is t2 is the dimension on the right side. Since the dimension on the left side is not equals to dimension on the right side, the given physical equation is dimensionally wrong. What can be done to correct the given physical equation? If we take the square root of the t square, that is t. So in such condition, dimension on the right side also will be equal to the dimension on the left side. If we take the square root on the right side for the physical quantity m by k, the given physical relation will be correct. So the correct physical equation is t equals to 2 pi square root of m by k. Now once again, cross similar question. Test dimensionally if the formula t equals to 2 pi square root of m by k, where t is time period, m is the mass, and k is the mass per unit length. Once again, go for the left hand side, go for the right hand side, you will get dimension. This correct physical equation is dimensionally correct. Take your time, pause the video, and once check it whether this formula is dimensionally correct or not. Within a minute you can check it. I'll proceed for the next problem. If the centripetal force is of the form of ma bb r power c, find the values of a, b, c. Here the centripetal force F equals to m power a, b power b, and r power c. Now in terms of dimensions, we'll write the equation as For the force ml t minus 2, it must be power ml t minus 2. M is the mass, m power a, b is the velocity, l t power minus 1 b, and l power minus c. Simplify the relation, will get as m power 1, l power 1, t power minus 2 on the left hand side, and m power a, l power b plus c, and t power minus b. From the this term minus b, and compare the powers or with the corresponding term. Just compare the exponent of the for the mass m equals to as the power 1, that is a equals to 1, b plus c is 1, and minus b is minus 2. Then a is already got the values, minus b equals to minus 2, that means b equals to 2. Replace in the b plus c, you will get c equals to minus 1, and these are the values of the a, b, c. If we need the physical relation, just replace the values of a, b, c in this equation. F equals to m a, b, m power a, b power b, and r power c will get released as f equals to m b square by r as a centripetal force. In this way we can find the values of a, b, c using the dimensions or simply physical relation. Okay, let's see one more problem. The velocity v of water waves may depend on the wavelength lambda, density of water rho, and the acceleration due to gravity g. Find the relation between these quantities by the method of dimensions. Let's see the according to the question, as per mentioned in the question, v is proportional to lambda rho g, but we are not familiar with the factor ABC. We have to find ABC using dimensional analysis. Rewrite this relation in terms of the dimension. Before b equals to just remove the proportional sign, k lambda power a, rho power b, g power c, where k is a dimensionless constant. Now in terms of the dimensions, rewrite the equation 1. We'll get for the velocity lt minus 1, k has no particular dimension, it is dimensionless constant. Lambda is the wavelength, dimension l. Rho is the density, ml power minus 3 power b, and lt power minus 2c. Rewrite this equation, we get in general m0 l1 t minus 1 and mb. There is only one term for the mb, and l a plus l power a minus 3b plus c. Second equation, second term, and for the time only t power minus 2c. As before, just equate the exponents of the similar quantities. For the b equals to 0 from the first, similarly a minus 3b plus c equals to 1, and minus 2c equals to b equals to 0, obvious, that is, then c equals to 1 by 2. Now replace the value of b and c in equation. This equation, a minus 3b, b is already 0, a minus c, a plus c is only left, and replace the 1 by 2, that is simply gives once again c as 1 by 2, and substitute the value, will get b also 1 by 2, sorry, a equals to also 1 by 2, b equals to 0, b equals to 0, a equals to 1 by 2 once again, and replace the values of a, b, c in equation 1. We get b equals to k lambda power 1 by 2, rho power 0, b equals to 0, g power 1 by 2 once again, and simply k lambda half, g half, or that is we can write b square is proportional to lambda g. In this way we can find a relation between the given physical quantities using the dimensional analysis. One more problem. The force F is given in terms of the time, and displacement x is given by the equation F a cos bx plus c sin dt. F is the force, x is the displacement, and t is time, and a, b, c, d are the unknown quantities. And what about the dimensions of d by b? Trigonometric functions are dimensionless. Your cos bx and sin dt are dimensionless. That means bx and dt have no dimensions. Bx and dt have no dimensions. So in terms of dimensions, they must be equal. Given physical equation once again is f equals to a cos bx plus c sin dt, and bx and dt are dimensionless because they are trigonometric functions. So dimensions of the bx must be equals to dimensions of the dt. About the dimension of b, we are not sure. We are not. That's unknown quantity. X has the dimension of displacement L, and t has the dimension of the. So d by b equals to L t minus 1. In this way, we can find the dimension of d by b. And this is the end of the lecture. Don't forget to subscribe and share, like and comment. And if there is any comments, queries, may suggest comment on comment box, or may forward through this email address readersimplifiedphysics@gmail.com. And for the Facebook, you may forward the message through the Facebook as well. Thanks for watching.